Hi guys, this time I've got something a little bit different for you. A while back I was revisiting my youth and playing my favourite game on my favourite console, which was Exhumed on the Sega Saturn, or Powerslave if you're in the US. I decided I was going to try and port the game to either the DS or the PC. Now, I know that the PC already has a version of the game, but it was built on the build engine which was used for Duke Nukem 3D, which in my eyes is nowhere near as good as the version that was on the Saturn, which was on the slave driver engine created by Lobotomy Software, which was the actual creator of the game. Now there is a reason that I'm telling you all this. Basically I needed to get a hold of all of the images from inside the game, and to do that I needed to read the PCS file format, which is what all of the images were stored in, or at least most of the images were stored in, on the Saturn game. So, I copied the files from the Saturn disk and began working with the hex editor. Now I think before I start talking about that, I should tell you about how I realised that the PCS files were actually image data. Now, to do that, I converted one of the PCS files into .raw format and opened it with Photoshop 7. From there I could see, using the black and white raw image data viewer, that it was several images stacked on top of each other with various bits of data between them. I did have to do a bit of trial and error trying to find out the dimensions that it should be, but from looking at the Saturn specs I could see that primarily it put out 320 pixels by 240, at least in the UK in PAL format. So I started off with 320 width and experimented to see how much of the data I could display in the raw image viewer by experimenting with large numbers for the height. I then discovered at the beginning of every frame there were 16 unrelated pixels, which means for each frame there's 16 bytes of header data. So I then opened up the logos.pcs file in a hex editor and had a look at the code itself. Immediately I could see where the header was, and that there was two separate values at the end in double word format. What I mean by double word is 32 bits of data. A word is 16 bits, and a double word is twice that, so 2 times 16 is 32. What I then realised was these two values at the end of each header, when converted from hexadecimal into decimal, equal 320 and 200. I could now figure out where the end of the first image was, simply by multiplying 320 by 200 and adding the 16 from the header section. Using the goTo function, I could get there very quickly. Then by using the findNext function, I could locate the next instance of 320 in hex, which will be the start of the next image. And from there I could get the next image's header start point and simply minus the start point by the end of the image data from the previous frame to get the footer size, which turns out to be 512 bytes. Unfortunately you can't see where the header starts on the video because for some reason my video capture program doesn't display pop-up boxes. So to quickly recap over what we've learned so far, we have one PCS file which is split up into several frames. Each frame is split up into 3 different sections: the header, the image data, and the footer. When we look at the header data, we can see that it's 16 bytes long. We can also see that the last 8 bytes are used for determining the size of the frame, starting with height. The footer data, however, turns out to be palette information. I found this out after studying the data for a very long time. And the way that the PCS file works is it works on a 16-bit color system. However, it only has a palette of 256 colors, which means that the 512 bytes of data at the end of each frame is 256 different colors, each in 16-bit format. Now initially I thought that the image data directly referred to the palette number, for example, if the image data says byte 4, it goes straight to palette colour number 4. However, I was wrong. As it turns out, there's an offset of 2 palette colours, which means for every byte value you get through for an image pixel, it has to be incremented by 2, so instead of it being palette colour number 4, it becomes palette colour number 6. This also means that the last 2 pixel values, i.e. 254 and 255, roll over to being 0 and 1. Again, after a lot of research, I found out that Saturn doesn't quite use RGB format, it uses BGR format, basically reversed. And of course the first pixel is the alpha channel, whether the pixel is invisible or not. Anyway, with all this in mind, I opened up C# and built myself a program around the data I gathered, and I've successfully managed to render images from most of the PCS files from Exhumed on the Saturn, though I did come across something rather strange. If any of you can tell me who this guy is, I'd be very grateful. But I know my image is rather pixely here and it's missing a few colours, but I think that has to do with the image format that the digital camera took at the time. Anyway, thank you very much for watching. There's several more videos on the way. I was attempting to fix an Amiga 500 Plus that I got for very cheap, but that looks like it's a bit of a lost cause, so we'll see about that one. I'm trying to add a homemade sound card, which sounds strange, to an old DOS PC. We'll see how that one goes. I've got the actual card working, I just don't have the audio amplifier working just yet, but I'm working on that. Anyway, yes, see you later.